All right, I realize now 7 and 8 I pretty much did in their entirety. I cannot get this to scroll nicely in class. I did the bottom two as actual problems that we worked through, and I solved all of these then. So I don't really want to redo all of that again. I will go ahead and put in my answer key, but we can do the top two. So let's just write down these. So as a reminder, for all of these, I'm using something like secant squared x is equal to, we just saw tangent squared x plus 1. We know that cosine squared x is equal to 1 minus sine squared x. And we have our last one. If I rewrote that, tangent squared x is equal to secant squared x minus 1. So these are the formats here on the right that we want to leverage to like be able to get rid of a radical in those problems up above. So this is sort of our guiding light for what goes into what trig sub. Again, you could also use the antiderivatives as a way to do that, or the triangle, right? There's like 3 different ways to show how we end up with something we can sub our way out of. So in this case, we could also notice that we have that sum. So again, as we're thinking about a triangle, the only way that these could have summed is if we make these the legs of our triangle so that our hypotenuse is 9 plus x squared. So that's another heads up that we're in tangent land. Doesn't help us figure out which one's opposite or adjacent, but still gets us into tangent land. But anyways, all 3 of those are ways to identify which substitution to use. For this one, again, we're in tangent. Our x needs to be 3 tan theta. That way, again, if you want to check your work on these, 9 plus 9 tangent squared theta. This will be, we can factor out the 9. And now this is the whole dang point. We can rewrite this as 9 secant squared, this radicand is 9 secant squared theta, and now we don't need to have a radicand anymore. That's sort of our mental check that yes, we chose the right substitution, we're good. Okay, so the next one is 4. We have a number minus x, we're in sine land. Sine x, cute. Sine x, sine theta. Again, we could check, I'm not going to on these. And then we talked extensively about the bottom 2 in class, but we ended up with a 1/3. 1 minus means we're still in sine land, sine theta for our x. As I said, this one was a little annoying. I would have actually set this up as being like, well, I need my 9x squared to be equal to sine squared theta. In fact, I should rearrange all of these so they all have thetas, right? That would just make my life easier in terms of me making, because I keep wanting to write x because I keep looking at these for guidance, which is my mistake. Let's go ahead. Theta, theta, theta. All right. And so anyways, we got all of this. We could say, great, lovely, let's freaking go. But this will get us back to, okay, we can divide the 9 out. I could do all that stuff. This one we had to do a little bit of completing the square. We ended up with x minus 3 squared plus 25. And so again, we needed this thing, x minus 3 squared to equal 25. We have a plus again? Really? Where was the secant lev? Just no secant lev at all. Judging past me for this one. But this is tan squared theta. If only I had tan squared theta there. Factor out the 25, do all the lovely work I did up top. And so that means x minus 3 is equal to 5 tan theta, which means x is equal to 5 tan theta minus 3. Gorge. All right. So we're at 4 minutes. I'll go ahead and do the top 2 problems because we did the bottom 2 in class for you guys in these videos.